Welcome everyone. This is a video I'm real excited about. This is going to be my entry for the Tool Fest 2021. And before we go any further, I just want to give a shout out to Emma's Spare Room Machine Shop. She's the one who puts this all together, coordinates this, and I just wanted to thank her for that before we go any further. I'd also like to mention that all of the other YouTube creators, go check out their videos as well. And you know, this is the time. This is a great opportunity, I should say, to show some support for the smaller channels. So you might find something that you really enjoy and like, and I urge everyone to subscribe. So, okay, without further ado, let's get to the project at hand, which is a dial indicator clamp that I made for my 12 by 18 Craftsman Atlas lathe. So let's get you over to the workbench over here, and I'll show you the finished tool, and then we will proceed to the video of how I went about making it. So, okay, so here's what I made. It's a clamp for a dial indicator, like I said before. This is an import, 2-inch travel, thousandths of an inch increments. You know, your run-of-the-mill dial indicator. And here's the finished tool clamp, or clamp if you want to call it that. It's 2 pieces that have some machining in it, 2 10/32 screws, and 2 roll pins, which I use as alignment pins to keep this bottom clamp straight. And this was made out of just scraps of mystery steel that I had laying in my junk box, as you can see. So so sit back, relax, and enjoy the video. You know, one of the most frustrating things I've ran into with my lathe is trying to get and find a way to make an accurate length of cut. And over the years I've tried several different systems, and just none of them really seem to work. I had the old tape measure on the carriage, but as you can see, there's just too much slop in the duct tape. Never really happy with that system. Even the knotted string trick just really wasn't doing it for me. You know, another old favorite I had was the old yardstick and pencil system, but it just really didn't give me the accuracy I really wanted to get. But then one day it just came to me. I could make something much better than any of the things I've tried before. Okay, so I got this kind of cleaned up a bit. Just wanted to get any burrs, things like that off, so when I do put it in the milling machine on the parallels, there are no burrs or anything sticking up. I could get it to wherever, just nice and flat. So before we head over to the mill, this piece only needs to be 1 3/4 long. So I'll take it over to the bandsaw, trim off some of this excess material. Don't see any point in milling all that extra material off if we're not even going to need it. So we'll head over there. We'll get that trimmed off. I'll leave plenty of material so I can square up the edges, and we could have a nice clean piece of metal to work with here. So okay, so the length of this part when it's finished is really not overly critical. I just scribed the line just to keep me semi straight when I cut this off. So I think I'll just get rid of that hole there, and that'll give me a solid block and give us something to work with a little bit cleaner when we're over on the mill. So let me cut this off. Alright, so I just finished trimming the the excess off of this block over on the bandsaw. And so I'm going to face this down to a point where it's cleaned up nice and flat, when no dings and dents and things like that in there. Then I'll flip it over, clean up the other side. Once again, these dimensions do not have to be critical, but I'd like to try to keep this material as thick as possible and have a nice appearance on it. So I got my homemade fly cutter in there, and so we'll start trimming this down, and we'll see how that goes. Alright, I'll get the other side cleaned up and I'll bring you back in a little while. Okay, so I got the four sides of this cleaned up very nice, and before I mill off the two ends, while I got the fly cutter in there, I figured I would work on the other piece here. So that's kind of got a rough saw cut on one end, so I just got a piece of copper wire pushed down there and crushed in to take up any differences in the edge there. So I'll go ahead and I will surface the top, skim that up, clean it up, flip it over to do the same as what I did on this piece here, and then when I put the end mill in to clean up the edges, I'll do both pieces with that same setup. So let's get going. Okay, so a little change in plans there. I thought it would be best to, after I did that first face here, I would use that against the back jaw as a reference and clean up the two sides, and that would give me a more accurate face to hold that when I fly cut the last face there. So okay, so both of these pieces, the two faces, are nice and clean, two edges nice and clean. So what we got left now is to get these pieces prepped, we'll use an end mill and come across and clean up these ends, and this will get trimmed down to the width of this piece here. So let me get things changed around here, clean up some of these chips, and I'll bring you back in a little while. Alright, so we got 3/4 inch end mill in there, and let's start cleaning that up. Alright, so I went ahead and laid out some lines. This is just more for a sanity check. 368 deep and 585 over. So I'll cut most of that out on the bandsaw and clean it up on the milling machine. Okay, so just saw I cut that off with the bandsaw and got rid of all that material. There's plenty of margin left here, so when I come back with the milling machine, I'll clean that up and we'll be good to go with that. So another benefit to doing it this way, I think, is that, well, all this material here would have been just chips and swath and a mess to clean up and unnecessary wear on an end mill. So these bandsaw blades are a lot cheaper to replace, and being the pack rat that I am, I'll probably throw this in the box and you know, maybe a little project I'm working on, I need a little scrubby scrap of steel like that. So, you know, a couple of benefits to doing it this way. Just a thought. Alright, so we got to drill a hole here. That is 1 inch and 113 thousandths over from this left edge, and from this top face down it's 303 thousandths. So I need to make a hole that's 377 thousandths in diameter. So that turns out to be a letter V drill bit. It'd be nice to have a reamer that size, but I don't have letter reamers. So we'll just we'll have to make the best with what we got. So start with a center drill and finish up with a letter V. Alright, so we have a 1/16 of an inch thick slitting saw set up, and we're going to cut a slot in there, or a slice in that, and that'll provide a bit of flexion to as a pinch point. So let's get cutting that. Alright, so we got to drill and tap some 1032 holes. So we'll refer to our old engineer's black book for quick reference. And we got a number 21 for the tap size, and clearance holes are number 9. So we've got all the goodies laid out here, and let's get started. Alright, so we're going to move in 3/4 of an inch. Alright, and we'll drill our first hole there. Okay, so we're on center in the y-axis, over 750 from this edge here, and we'll start with a center drill. And we'll move over another 3/4 of an inch. That'll be 1.5 inches from this edge here. Number 9, that'll be for the clearance hole. That'll just get drilled in this top section here. So we'll drill that. This hole here gets drilled, this number 9, all the way through. Okay, so we got a 1032 tap in here, and we'll be tapping into this bottom section here only. Okay, I don't know if you guys can see. Alright, so this top part here has got the number 9 clearance hole. The bottom section is drilled with the number 21 drill bit, and that's the tap size. So got to set up in a spring-loaded tap center, and we'll tap that all the way through. Alright, that feels like that's all the way through. Yep. Alright. Because I have an 11/30 seconds I mill in there, and we'll go down 100 thousandths. Okay. Alright, so this is the bottom of the clamp, and this This is still on center. Both pieces are the same width. And this is 1/2 inch up from this back edge here. And this has got to get drilled and tapped with another 21 drill bit, so we could put a 1032 tap through that. So, as always, start with a center drill. Okay, so I got to drill 2 holes, each of them in line with this drilled and tapped hole, and it's going to be 375 over in each direction, and each hole is going to be a number 40 drill bit, which will give us clearance for a alignment pin. So let's get these 2 drilled. Okay, so this is centered back over this again, and we'll drill 2 5/64 holes, 3/8 on either side of center. So let's get started on that. This is a 5/64 drill bit, and we'll be going down a depth of 200 thousandths. So let's back this up a little bit here and zero out the coil, and now we'll go back to 375. Almost there. Okay, right there. So 375 on the y-axis in either direction, and so let's get drilling. We're going to go down 200 thousandths. Okay, so here we have all of the pieces. All the machining is done. Holes are drilled. Pieces milled and cleaned up, but I think we'll spend a little bit more time, and we'll just give this a little bit more professional look to it. So spent a little bit of time doing it. Let's spend a little bit more time and really make it look good. Alright, so I probably spent about an hour and a half, close to 2 hours, and I went through the grits 200 up to 600 and kind of polished up each of the faces. Just get rid of any of the tooling marks, and so, you know, in the absence of a surface grinder, just use these diamond stones here, and I'm kind of happy with how everything looks. So let's move on to the next step, and let's get them blued. So I got all of the pieces sitting in this nice little bath of acetone here, trying to get all the oil from the machining off, get it all cleaned up, and all that slurry from the from those diamond stones, and we'll get all of that cleaned up here. And so I want to make sure I don't get any oil from my skin back on here. That might cause a problem with the bluing to take. So I'm wearing these little plastic gloves here, and get these guys out. They've been soaking for a little while there while I've been getting everything ready. Okay. Okay, I think I got every end covered here pretty good, and we'll let that sit for like a minute, and then I'll just wipe it off, and we'll put a coating of oil on it. And we'll just rub that in all over. Alright, so we got the 2 roll pins in there, and so those will be alignment pins for that, and for the clamp, and for the pinch bolt. Alright, so let's get it over to the lathe and check it out. Alright, so moment of truth. Here we go. So I already put the dial indicator in here, clamped that down, and I took into account when I made this piece that it can slide back here. So this edge of the way will register against this part, so it'll always sit flat and the indicator will be parallel, so to minimize cosine error. So let's see how this clamps on. That's not moving anywhere, and now we have it. So now you'll be able to make accurate cuts and watch the length of travel there. So that's it. It's all done. The dial indicator holder for the Craftsman Atlas 12-inch lathe here is complete. Well, I hope you guys enjoyed it. Thanks for watching. Check out all the other creators that have took the time to make a tool for Toolfest 2021, and if you haven't done so, I'd appreciate it if you'd subscribe. Alright, stay well everyone, and see you soon.